talk about the point slope formula. Suppose I'm given a fixed point, x1, y1, and I know that my line has a slope m. Then any other point on the line, xy, will satisfy the slope formula, y minus y1 divided by x minus x1. So let's multiply across and switch sides. I see that when I do that, I get something called the point slope formula, where I can write this as y minus y1 is equal to the slope times x minus x1. What I like about the point slope formula is you can immediately read off the slope and what your what your fixed point is on your line. And this is true for every point on the line. So we see the point slope formula is not unique like the y-intercept formula is. So find an equation through the line 3, -5, having a slope of -2. So the point slope formula is y minus y1 is equal to m x minus x1. In this case, x1 is 3, y1 is -5, and m is -2. Substituting straight into the point slope formula, I get y plus 5 is equal to -2x plus 6. Continuing to solve this for y, I get y is equal to -2x plus 1. So my slope is -2 and my y-intercept is 1. Suppose I want to find the equation of a line through -4, 3 and 5, -1. The first thing I want to do is find the slope. So that is 3 minus -1 divided by -4 minus 5, or -4/9. And now you can use either point um, to, to use in the point slope formula. In this case, we used -4, 3. And when you have fractions and you're going to wind up with a lot of fractions, the first thing you want to do is clear the fractions by multiplying by the least common denominator, which is 9. Then we want to distribute that 9. And we did request it in standard form. Standard form of a line, remember, is ax plus by is equal to c. So the standard form of this line is 4x plus 9y is equal to 11. Now, suppose I want to verify my results using the other point. So I go back to my equation, my point slope formula, and I substitute in 5, -1. I clear my fractions, and lo and behold, I get the same answer. Now the slope-intercept form is y is equal to mx plus b. All right, the y-intercept is 0b, and the slope is m. Now when we look at the general equation of a line ax plus by is equal to c, we can see that the slope is minus a over b, and the intercept is 0 c over b. Don't memorize it. You're always going to be able to figure it out. So find the slope and the y-intercept of a line of equation 3x minus 4y is equal to 12. So we put it in slope-intercept form, which basically means we solve for y. So we get y is 3/4 x minus 3. The slope is 3/4, and the y-intercept is -3. Find the equation of a line through -2, 4 and 2, 2, and graph using the slope-intercept. First, you need to find the slope. That's change in y over change in x. And now we're going to substitute 1/2 in for m in the coordinates of one of the points, either 2, 2 in this case, and solve. And we see that 2 is minus 1/2 times 2 plus b. So I solve this and I get that b is equal to 3. I could have picked the other point and plugged in also. So the equation is y is -1/2 x plus 3. So when I graph it, I graph my point, and I see that the slope is down 1, right 2. So I could have graphed 2 points and connected, or used 1 point and used the slope. Now use a graph to find the slope, the y-intercept, the x-intercept, and write the equation of the function. So this graph goes up 5 every time it goes over 2. So the slope is 5 halves. The the graph intersects the y-axis at 5, 0, and the x-axis at -2, 0. So the y-intercept is 5. The x-intercept is -2. The equation of the line is y is equal to mx plus b, so it's 5 halves x plus 5. Now, you remember we discussed vertical lines and horizontal lines. A vertical line through a point AB is just x equal to a, and a horizontal line through a point AB is y is equal to b. Here we see for the vertical line, we have no y equals. And in the horizontal line, y equals mx plus b, we see that the slope is 0. So that term goes to 0. Now we say two non-vertical lines are parallel if and only if they have the same slope. And then we see that two perpendicular lines have the slopes have a product of -1. So m1 times m2 equals -1. If I were to solve this, m1 is -1 over m2. A lot of times we say perpendicular lines have a negative reciprocal slopes. Now, for vertical and horizontal lines, we know they're perpendicular, all right? The slope of a horizontal line is 0. And the negative reciprocal of that, well, you can't do 1 over 0, so it's undefined. So we can't mathematically solve it. We just know that uh, a perpendicular line to a horizontal line is vertical and vice versa. Here's a summary chart. I recommend you make sure you jot down and have in your notes and understand. So suppose you want to write an equation in both slope-intercept form and standard form that passes through the point 2, -4 and is parallel to the line 3x minus 2y equals 5. The first thing you need to do is to write in slope-intercept form. So I'm going to solve my line, and I get y is 3 halves x plus 5 halves. From here, I see my slope is 3 halves. So now I have a slope of 3 halves, and I want it to be parallel to the line going through the point 2, -4. So we go back to point slope form. The slope is 3 halves, and we substitute in the point 2, -4. And now we want to solve this. We distribute and solve for y. Y is 3 halves x minus 7. Putting it in standard form, it becomes 3x minus 2y is equal to 14. Suppose I want to write the equation in both slope, intercept, and standard form of a line that passes through 2, -4 and is perpendicular to 3x minus 2y equals 5. We again still want to solve this equation so that we have y is 3 halves x plus 5 halves. So again, we have the slope is 3 halves. But now the slope of the perpendicular line is the negative reciprocal, so it's minus 2/3. So we go back to the point slope formula. We substitute in the point and our negative 2/3 slope and distribute, solve for y, and I get y is negative 2/3 x minus 8/3. In standard form, that's 2x plus 3y equals -8. Now, when we model from data, the first thing I want you to do is make a scatter plot, a graph, and find the equation that models your data. So, suppose we were to have this data on annual tuition rates um, at for your colleges. When you graph the data, you see this looks pretty much like a line. So we're always going to graph our independent variable, the years. Time is always on the x, and the cost is on the y. You, of course, may have to adjust your graph a bit so it fits. So you want an equation that models the data. And in this case, we're going to pick the points 1, 6,695, and 3, 7,703. It didn't matter which two points we picked. Those were just two really nice points. So we're picking the data that goes through those 2 points, and we're going to approximate it with a line. So we find the slope. It's 500. And then we can pick either point for x1, y1. When we do that, we get y is 504x plus 6,100. Now, using the equation from part A, we can predict the cost in 2015. In 2015, x is equal to 6. So substituting in 6, we get the tuition cost will be $9,215.